In the video on functions, we talked about the basic construction and idea behind a function. The idea is that we start with some variables, we use those as inputs to the function, it works with those variables, does something, and then maybe it returns a single value. I showed you how to declare a function by declaring the type of the value it returns, or void if it returns nothing, the variables that are the inputs, and the return statement that lets us return a value. Knowing all those mechanics is great, but what are they really good for? They're good for all sorts of things. In this video, I'll return to the demonstration using stacks of ellipses, and I'll show you why functions give us so much power. Here's our program again, and I will briefly recap what we have. The first few lines are set up, and they do stuff we've seen before: create a graphics window, smooth, turn off the stroke. The draw routine just draws the background color, creates three bright colors, yellow, cyan, and magenta, and then calls Drawstack 3 times. So what is Drawstack? This is the key. Drawstack is defined here. It's of type void. It doesn't return anything. Its name is Drawstack. Its first input is a float, and we're going to call it CX. So as far as the body of Drawstack is concerned, all the lines of Drawstack between the opening curly brace and the closed curly brace, the variable CX has the value corresponding to the first number in each of the function calls. So in this call, when the first value is 500, for the duration of Drawstack, the variable CX has the value 500. So there's a center X, a center Y, a float for the width, a float for the height, and a color variable for the color we want to draw. I pull the color apart into red, green, and blue values. I fill with the original red, green, blue, and I draw an ellipse, centered at the center with the given width and height. Then I create a slightly darker color by multiplying everything by 0.8, and I draw an ellipse where the width and height are also multiplied by 0.8. Then I make an even darker color, multiplying the red, green, and blue values by 0.6, and I tell processing to use that for the fill. And I draw a yet smaller ellipse, multiplying the width and height by 0.6. So let's go ahead and run this and remind ourselves what it creates. 3 stacks of ellipses, yellow, cyan, and magenta. Suppose we want to add a 4th stack. If we didn't have Drawstack, we'd have to manually create 3 ellipses and manually set 3 more fill colors. But of course we do have Drawstack, so we only need 2 lines. So with just 2 lines of code, 1 line to create a color, 1 line to call Drawstack, I can now, if I run this program, I've made a 4th stack. Let's look a little bit more into the mechanics of Drawstack. Notice that Drawstack is of type void. That means it doesn't return anything. Tell you what, let's break the rules and return something. We can return anything. How about the number 55? So what happens if I try to run this program? I've told processing, this doesn't return anything. And then I say, here's a value to return. What will it do? If I run the program, we get an error. And the error is beautiful. Void methods cannot return a value. Well, yeah, we declared this of type void and we're trying to return a value. You can't do that. So, okay, that's great. Let's get rid of the return statement, but let's do the opposite problem. So now it's of type void. It doesn't return anything. But tell you what, let's suppose we tell processing it does return something, a float. So now I'm saying Drawstack returns a float, but then of course I never do it. There is no return statement. What happens if I try to run this? Another error. And what does the error say? This method must return a result of type float. Well, yeah, because we told it. This returns something of type float. So we don't want to return anything. I'll make that of type void, and now everything is okay. Part of the beauty of drawing all of our stacks in a function is that if I change the function, I change all the stacks. So I'll tell you what, let's make the middle ellipse very small. I'm going to make it just 0.2 times the width and the height. And now all the stacks of ellipses have that new behavior. So that's really nice. We can just change it in one place. Tell you what, let's make an even bigger change. And now I'm going to change the calls to ellipse to rect. Now we know that rect interprets its arguments in a different way than ellipse. The first two values are not the center x and y, but the upper left x and y. But still something interesting should happen, so let's run it. And this result makes sense. We're always handing it the same upper left value rather than a center value. We can fix this, of course, by offsetting the center using half of the width and half of the height. I'm not going to do that here because it's just a bunch of typing, but if that intrigues you, I invite you to go ahead, take this code, and make that change so that now the rectangles stack up one within the other just the way the ellipses do. Let's take out those calls to rect and put them back to calls to ellipse, but just for fun, let's leave one of the rects in place. So suppose we make that one an ellipse, the second one a rectangle, and the third one an ellipse. It'll look pretty weird. The point here is that because all the stacks are being drawn by the function, making a change to the function means a change to all the stacks. So let's put that back. Let's return that to being an ellipse. And I'll run it just to make sure we have things right. But tell you what, let's reverse the colors. So I'm going to make the original RGB sort of dark. We'll multiply the red, green, and blue by, say, 0.2. Whoops. The middle ellipse will multiply, say, by 0.5. And then the outer ellipse will multiply, say, by 0.8. I'm sorry, that's the inner ellipse. So the colors now get brighter as they go in. The color we're handing to the function is the color of the innermost ellipse, and we've completely changed the visual appearance of the result. This is really a nice thing. We only have to change things in one place. In part 2, we'll see how to use functions another time to make this program even shorter and more flexible.